Alright, we've got a bullet shot into a piece of plastic, a plastic block, and it penetrates the block by 0.4 meters. So the initial speed of the bullet is 490 meters per second. Our VF here is 0. And so what is the magnitude of the acceleration as it's penetrating the block? And assume that the force or the acceleration is constant. So in this case, we've got VF equals VI plus AT. So our acceleration can be written as minus 490 over t meters per second. That's our VF is 0. So that we can write our acceleration that way, but we really only have a displacement. So our displacement can be written as this. And again, we're missing a time. Our xi we're defining to be 0. So we can define a time, or we could have solved for time here instead. What did I do? Okay, yeah. So we have 0.4 meters is equal to our initial velocity, so 490 meters per second, times our time, plus 1/2 minus 490 meters per second over our time times our time squared. So that's going to cancel one of those. And so our 0.54 meters is equal to 490 meters per second minus 1/2 of 490 meters per second times our time. And so we can solve for our time as 0.4 meters over 245 meters per second, which is equal to, apparently I didn't bother solving for that. Okay, so that our acceleration is minus 490 meters per second over our time, which we can write as minus 490 meters per second over 0.4 over 245. Which this flips around, so this would just be 490 times 245 all over 0.4, which is minus 300,125 meters per second squared. And so then the magnitude of our acceleration is the unsigned value, which is just 300,125 meters per second squared. Okay, so to check the solution, that is indeed what was found. So that is correct.